Lesson 7, Components of a Vector, Part 2. Components of a vector in 3 dimensions. In Figure 19, OS, OY, and OZ, OS, OY, OZ are 3 mutually perpendicular axes. OABCS PQR is a parallelepiped, and this is a solid figure having 6 faces or parallelograms, constructed by dropping the normals RQ, RS, RB to the plane SOZ, YOZ, and SOY, respectively, from arrow. We attempt to find the components of the vector O arrow in 3 dimensions. In this lesson, we are considering components of a vector in 3 dimensions, and so we also have 3 unit vectors I, J, and K in the direction of OS, OY, and OZ axes respectively. Let vector OA be equal to S vector I, vector OC equal to Y vector J, and vector OP Z vector K. Let arrow be equal to vector O arrow. It follows that vector O arrow is equal to vector OA plus vector AB plus vector B arrow. You have it in this form and this form. That is simply vector arrow equal to S vector I plus Y vector J plus Z vector K. As in 2 dimensions, addition, subtraction, and scalar multiplication of vectors are done component wisely. For instance, if vector arrow 1 is equal to this, vector arrow 2 is equal to this, and H is scalar quantity, then the sum of the 2 vectors is equal to this. So you take S1 vector I plus S2 vector I, you factor out vector I. You have the same for the second and third components. For the difference, you have it in this form, and this is scalar multiplication. H times vector arrow 1 simply means using H to multiply each component of vector arrow 1. Modulus of the vector arrow in terms of its components. From figure 19, O arrow square is equal to OB square plus B arrow square. That is Pythagoras rule. O arrow square is equal to OB square plus B arrow square. O arrow square is equal to OA squared plus AB squared. This is equal to this, then plus B arrow square, follows by these results. Now, the modulus of vector arrow square is equal to s square plus y square plus z square. And to get the modulus without the square, you simply take the square root of both sides. If the unit vector in the direction of vector arrow is denoted by vector arrow, then vector arrow is equal to arrow over the modulus of arrow, and you have it in this form. This is the expression for a unit vector. If you divide a given vector by its modulus, what you have is the unit vector in direction of that vector. Let theta, alpha, and beta be the angles which O arrow makes with OS, OY, and OZ axes respectively. Then the first direction cosine cos theta is equal to the first component over the modulus. You have this result. The second direction cosine is the second component over the modulus. You have this result. The third direction cosine is the third component over the modulus. You have this result. Cos theta, cos alpha, and cos beta define the direction cosines of the vector O arrow. Examples number 18. Find the modulus of the vector. You have vector A equal to 10 vector I minus vector j plus 2 times vector k. Solution. This vector has 3 components, so the modulus of vector A written in this form is equal to square root of square of the first component plus square of the second component plus square of the third component. You have square root of 10 square plus minus 1 square plus 2 square. That is square root of 100 plus 1 plus 4 equal to square root of 105. Example 19. Find the unit vector in the direction of this vector. Solution. Let vector M represents the given vector. Let vector U be the unit vector in the direction of vector M. So the unit vector U is equal to vector M over the modulus of vector M. You obtain the modulus, which is equal to square root, then you square the 3 components and add them respectively in this form. That is square root of 49 plus 4 plus 9, and that is square root of 62. Therefore, the unit vector is 1 over the modulus times vector M. Example 20. Find the direction cosines of this vector. Solution: let vector P be equal to the given vector. To find the direction cosines, we need the magnitude or the modulus of the given vector, and that is square root of 146. Let cos theta, cos alpha, and cos beta be the direction cosines of vector P. Therefore, the first direction cosine, cos theta, is equal to the first component 4 over the modulus. The second direction cosine, cos alpha, is equal to the second component 3 over the modulus. The third direction cosine, cos beta, is equal to the third component minus 11 over the modulus, square root of 146. End of lesson 7. There is every need for you to be saved if you are not, because the Lord Jesus Christ is coming very soon. Some will be taken and some will be left. Live righteously and be prepared. Goodbye.